So, Juan, can you tell us who you are, your name, how many years you've been working here at Pico Veleta?
Well, my name is Juan Peñalver. I am working here as the Deputy Station Manager, but my main task is also working as an engineer for the operation of the observatory. I am working for more than 30 years, and then one main activity is the operation of all the instruments and the installation of new equipment.
Okay, so what kind of measurements is done here in this laboratory? What people are studying?
Well, this is an observatory. Then the laboratory is in the universe. What we are doing is to observe the universe as some specific electromagnetic wave. Some electromagnetic wave not visible for our eyes. Then we can investigate many phenomena, many behavior of the universe, what is not visible with our eyes. For instance, the formation of a star or the origin of the universe with the Big Bang, many thousand millions years ago, and also some interesting area with the interferometry of the VLBI is the investigation of the black holes.
Okay, it's very similar studies than in the Bure Plateau Observatory in France.
Both observatories are dedicated to the same wavelength, then the same phenomena in the universe, but the difference is at the Plateau de Bure they have at the moment 7 antennas, and then they produce or they synthesize an interferometer. With the interferometer you have more resolution in the sky, but not so much sensitivity as here. Here we have only one antenna, but with a bigger size, with a bigger diameter. Then our beam in the sky is broader, but on the other side we have more sensitivity. Then basically the difference is in Plateau de Bure, more resolution, less sensitivity. Here in Pico Veleta we have more sensitivity, less resolution.
So scientists are coming from all over the world. So can you explain how it works, the proposal system? People are applying for observations time?
Typically, in 1 year, about 80 teams are coming from the different countries around the world. Mainly they are coming from Europe, from the country Germany, France, and Spain, because these countries contribute to the operation of IRAM. To make observation with this observatory, they have to apply according to some investigation activity. When this application is studied, some committee is deciding which projects are more interesting. Then these projects are accepted, the astronomers are coming here, they carry out the observation they plan to do, and then typically after that they produce some scientific publication.
So I understand it's an international collaboration. Like one country alone couldn't build such a big equipment. So it's money coming from different countries.
That's true. The money is coming mainly from the country France and Germany, but also there is contribution from Spain. There are 3 institutes behind IRAM. In France is the CNRS, in Germany is the Max Planck, and in Spain is the IGN. Then this partner collaborate for the operation of the IRAM in both sense. The observatory in Plateau de Bure, the observatory here, and also the main headquarters in Grenoble.
So what people are usually wondering is why do you build those telescopes so high in those places? Like here it's 2,800 meters altitude, in Bure it's 2,500. So why?
Well, the reason for that is because the atmosphere is more transparent at the electromagnetic waves we are observing. Then we reduce all this pollution from the atmosphere, mainly the water vapor. The precipitable water vapor at this level is much less than at the sea level. Typically we are working with an amount of water vapor between 1 millimeter and 6 millimeter. And that is the reason why the observatory are installed at this height. Here we are very close to 3,000 meter height. In addition, the place must have many days during the year with good condition for observation. I mean, no clouds, no raining, no snow. And that is why this place in particular was chosen.
Juan, you mentioned VLBI, Very Large Baseline Interferometry. Can you quickly explain what it is and the way it works? I heard you need a very precise clock.
Well, with the VLBI, several observatories, several antennas around the world are working simultaneously. I mean, here in Spain, but also in France, in Germany, even in North America and South America. Then with all the antennas working synchronously, we synthesize a very big antenna with the diameter, the separation between all the different observatories. Then in order to achieve this observation, we need a very precise clock. This clock must be an hydrogen maser. We have here an hydrogen maser. The other observatory must have the same kind of oscillator, the same kind of clock. Then all these clocks are synchronized with the GPS satellite, and then simultaneously we are observing the same object in the sky. Later, the information from the different antennas, from the different observatories, are combined in order to get a very small beam giving a very detailed information from the part of the sky we are observing.
And now what's next in the next years?
Next, this antenna has a long time operation, more than 30 years, but is still very competitive at the international level. The main reason is because we have made improvement, one thing in the antenna, with the adjustment of the panel in order to get the maximum possible resolution, but on the other side, different equipment have been modified, have been changed for the new state-of-the-art equipment, mainly receiver. About what next, at the moment we have installed a new volumetric camera. The main significant feature of this volumetric camera is because it has about 5,000 pixels. That means simultaneously, or in one shot, we can get a picture from the sky. Compare it with the old time when only single pixel receiver were used and only one pixel from the sky was taken at any time. At the moment we are able to collect information from 5,000 pixels simultaneously. This is a camera called NICA from several institutes. It's an instrument coming from France, from several institutes in France, and this instrument is very powerful and very promising for the future.
So many years of measurement coming still.
Yes, at the moment it's still a very demanding instrument with many ambitious projects in mind.
Thank you, Juan.
You're welcome. Thank you to you.